So far you are doing good, but you made a mistake. Did you see your mistake? The mistake that you made in the first line, you said 2 in brackets x plus h squared, which is fine, but you say minus x only. Minus x. So you have to repeat. You did a mistake. So you can repeat. Remember, wherever there is x, you must put x plus h. Then the equation says minus f of x. It minus with everything with 2x squared minus x. No. You are making mistake again. Ne? Remember, wherever there is x, you put x plus h in that equation.
Where?
There is the equation says 2x squared plus minus x.
Yes.
Where there is x also, you must put x plus h. Is the whole equation. When we say x plus h, when you substitute x plus h, you don't only substitute in x squared, you substitute wherever there is x in your equation, in your function, in your f of x. It's like, in other words, when you are saying f of x plus h minus f of x. Did you get what I said?
Yeah, I'm completely lost.
Where there is x, you must also put x plus h. Is it the equation is saying 2x squared? Look at the equation, is 2x squared minus x. Why minus x? You are not substituting x plus h, you are only doing it in x squared.
But then isn't it supposed to be minus 2x squared minus x over h?
No, it's going to be 2x squared. Okay, listen properly. It's going to be 2 in brackets x plus h squared minus in brackets again x plus h. Minus again 2 in brackets 2x squared minus x. Did you get it now? When I say whenever there is x, you must substitute first x plus h. When you are done with all the way there is x, then when you are done with substituting x plus h,
incoming call from Lucifer identified by Truecaller.
when you are done with substituting x plus h, then you see is if there was 1 there, you are going to say plus 1, then you say minus.
Incoming call from Lucifer identified by Truecaller.
Come on, class. And then what's going on here?
Hello?
Something is wrong.
Okay, the app.
Oh yeah.
Okay. Yeah, now it's fine. That's what I was talking about. So now when you say minus, remember you must use before, so that you don't make a mistake. You say negative, you say bracket 2x squared minus x. So that, because now you did forget to add plus, is brackets minus in brackets 2x squared minus x, so that negative you multiply inside there, so that you don't make a mistake. Maybe your equal sign, because it's a long equation, you can put it closer, like you can shift it a little bit from closer to f of x, so that you can have a space. No, now you are making mistakes, because you are saying plus. That plus, it happens when you say negative times 2x squared, negative times what? Minus x. You see. So even there, when you wrote plus, you made a mistake there, because you have negative already. Unless otherwise, if you are saying it's minus 2x squared plus then you don't have to put, when you already multiply by negative everything, you don't have to put the brackets. So on top, which means if you take out that bracket, then the equation will be fine. Yes, that's what I'm talking about. It must be like that. It's fine. You can ignore that because of the space. I can see that is x. Now you see what you are not taking. Okay, when you have a bracket, if you say minus, when you have minus in brackets x plus h, or it cannot be, it can be anything. That negative, it multiply everything. Don't forget about that. Yes. Those are mistakes that when you make them, you are getting wrong. You will know how to do something, but you get wrong because of that small mistake. So don't forget about those small mistakes. Remember, also minus x plus x, they can cancel each other. Why didn't you cancel them out?
Oh, I didn't see.
Why are you writing? Okay, yes, it's fine. You can proceed. You forgot to write limit now. What happened? Because if you don't write that now, it's 0. You get 0. So mathematics is teaching you how to be logical and how to be precise. Your things must be logic and it must be precise. So that's why you are doing maths. So that whatever that you do, it must be in order. So that's why in mathematics, when your things are not in order, you can get a right answer at the end. But if you get the person who understands maths, they are going to give you 0. And nothing will say, even say, when you see, but the last answer is fine, but your steps are not right. You are not writing completely. It makes it wrong. Yes, you are fine. When you get to that step, if you are going to substitute 0, you don't write limit now. You just write the answer. You don't do that. That becomes wrong now. So you just write the answer yes. Then you just say yes. That's what you must do. Perfect. You see how your steps. So the point now, what you must look at, did you see how the things that I corrected you, there are things that now in 2 minutes, write down, then check them and write down, or if you can write, if you will forget, where you were making mistakes. The problem that I saw now is that when you multiply in the brackets, if you have a negative, let's say it's negative in brackets x plus something, you don't multiply everything. That's the first mistake that you're doing. And the second mistake is that when you were substituting, you thought maybe you only substitute on x squared, even if the equation, you can be given an equation whereby equation can be f of x equals to maybe 2x squared plus x minus 1. So when you substitute, you're going to substitute in x squared, you also write that minus 1. Then after this you say minus what? Minus f of x, which is 2x squared plus x squared minus 1. So let me show you a little what I'm talking about. So I'm gonna share a small, just for a few minutes, just to show you what I'm talking about. You can just stop sharing just for now. Okay, it's fine. So what I'm saying, is that if you have, let's say, f of x, I just want to show you f of x. So your f of x, let's say, equals to 2x squared minus x plus 5. So when you write your limit, your f prime of x, I'm not going to write everything, I'm just showing you how you should write it. Your f prime of x is going to be equals to, in the first principle, is going to be equal to limit when h approaches 0 of what? 2 in brackets x plus h squared minus x plus h plus 5 minus again f of x. When I say f of x, I'm going to say brackets 2x squared minus x plus 5 over h. So if you have noticed here, check the way I've written this equation, you will see that in this equation here, I substitute where there is x squared, I substituted x plus h. Where there is minus x, I say minus. I substituted x plus h. Where there is plus 5, here it's supposed to be plus. I said plus 5 again. Then I start again because the equation says f of x what? Is f of x. I'm just writing this x plus h minus what? F of x. Where there is f of x, the over h. Where there is f of x, I said minus, because it says minus, I said brackets. I substituted everything that is for f of x. Do you see that? I included everything there. So that's what you have to do when you are dealing with this subject, when you are doing with this first principle, when you are finding the limit using the first principle. So you can now present again. Okay, are you presenting? We can continue with the questions. Yeah, you are determining the 7.2 0.1 dx in brackets x plus 1 in brackets 3x minus 7. Did you see it? All right, so let's proceed. Let's see what's happening. Okay, every time when you are doing that, ne, the other you are doing it right, but you can stop then a little bit first. Okay, you are doing everything right, ne. When you are just multiplying inside, ne, you are simplifying. So you must also indicate that it's still under dx. You must still write dx. You say in brackets, you multiply everything. Then when you start differentiating, that's when you stop writing dx. You don't say equal to. You will just say, you can say equals to, then you say dx. You put like that, the way it was here. Yes, you say dx in everything. That's the good way to write it.
So is it right?
Yes, the way you wrote it is right. Keep writing it until when you are simplified. Then after when you differentiate, you stop writing the x.
Like this?
Yes, even there you put a bracket. Yes, even on top there. Remember, what you just did so far, you haven't differentiated now. So I'm not sure what you're writing. Oh, because maybe you can still erase that one. Then now when you are differentiating would mean when you are taking 2 down the way we do it, you just write equal to only. You can erase that 3x squared minus 4, it does not mean anything. You start properly. You write nice things here. Even, yeah, it's fine. You see, that's perfect. That's very perfect. So now before you erase everything, check how you answered that question step by step, the way I was even guiding you, how you answer. Then exactly the way you answer, when you find the same question like this one, similar questions, you do exactly the same way that I have showed you. That's how you need to answer it. The moment when you write it like that, it's perfect. Even the person who is marking, even if that person knows you or he want to give you wrong 0, he will even understand, oh, this person, if I do this, this is I'm committing a sin. This person knows what she is doing. So let's proceed. Do you have that question paper, right? Hello?
Hello.
Do you have the question paper with you there? Okay. So now we are going to question number 8. So question number 8 says, given f of x equals to x in brackets x minus 3 squared with f prime of 1 equals to f prime of 3, which is equal to what? 0, and f of 1 equals to 4. Ne? They are given you that. Then the question says, show that f has a point of inflection at x equals to 2. So when you show that f have a point of inflection at x equals to 2, you differentiate f of x first, then you differentiate again f of x. Ne? When you differentiate f of x, let's do it. Differentiate f of x first. That's nice so far.
And then I still keep the bracket.
Yes, you can solve that. Why are you writing 2x?
Aren't I differentiating?
When you differentiate, you don't do that. If you are differentiating, first simplify that equation so that you don't have a problem. You know how to simplify, right? That's what you must not hurry up in maths. I never hurry up. That's why I got 90%. The reason why I didn't get 100 is because the time I was happy too much when I hurry up, I lost focus. I know. I remembered. I lost focus. I started doing things that I started taking the formulas. I remember I was too much happy that the question paper was easy. Then after that, when I lose focus, then I got that 10 marks wrong at the end. Then when I was out of the exam, there was nothing I can do.
then now I differentiate.
Now you multiply, there is x there. X must multiply everything first.
Oh, okay.
Okay, so now remember what you did is fine, but you didn't indicate when you start. You must show, you can say, remember everything is not f of x, the other way you were simplifying. After when you are done simplifying, the last equation you can say what, f of f prime of x, to show that now you are differentiating the one when you started differentiating. So the way you have written them, if you can check also yourself, it's like it's one thing, but you didn't start differentiating there. You were still simplifying there. You started at the end one, the last one. You see the mistake that you are making. It's a small mistake that it's a common sense mistake. You get what, do you look at what the mistake that you make? So what I'm going to advise you now is that every time when you are done doing something, check what you did and try to reason a little bit. Or did I my format fine? Is there something that I can show that somebody who is marking can know what is happening there? You get my point, ne?
Yes.
All right, let's proceed. And then now you have done that. You are not yet done, ne? Yes, fine. Now because this one is for inflection, I didn't show you. I'll tell you how you do it. You differentiate again. You see the f of prime x. You're going to say f. You write 2 prime. That's the on top there. You say 1 dash dash 2 of them. Then you differentiate the second one again.
Which one?
On top, you see the answer that you got, ne? We are differentiating it again. Then that's when we say a second differentiation. You differentiate 2 times.
Okay.
You can just erase on top there. You leave the f prime first. Then differentiate again. When you write f, you write those dot 2 times 1 on top. 1 to 1, another, yes, f of x. Then equals to differentiate that equation, answer again. No, you are not differentiating now. It's better like you didn't write f those 2 times. If you are copying again something that you can see there. So erase what you erase the, yeah, you didn't do anything. You don't write to differ, like when you, yeah, now you can start differentiating, is fine. The only thing you need that I really see is that you really have to be careful. You are good with what you are doing, but you are not being careful. That's what I can see so far. You really have to pay attention in each and every step that you are doing. Okay, now when you have written that, you can say, the question says at point what? At point x equals to 2. Then you can say, show that there is, that f has a point of inflection at x equals to 2. Now you can say f second prime, you substitute, you write where there is x there, you write 2 equals to, you substitute 2 in 6x minus 12.
What?
F second prime, you say brackets 2 close brackets equals to 6 in brackets 2 minus 12. Yes, so that's how you have shown, that's the point of inflection, the one, the answer, the results that you are going to do. Where there is x there, put 2. Where there is x there, there is also x there in the other side, you must put 2. You must write 2, because is it you are substituting 2 there, you are showing that I'm substituting 2 equals to 0. Yes, then you are done. That's what they wanted you to do in that question. It's fine. So I have to show you that when you have inflection point, you differentiate 2 times. You must remember that the way you did now is fine. So sketch the graph of f, clearly indicate the intercept with the axis and the turning point. Sketch the graph of f. So now we are going to that question where we have to sketch this equation. So now when you are sketching, so far in this equation they already show you that f prime of 1 equals to that, which is equals to that. You don't have to have a problem with that. Then what they are saying in that equation, when you substitute f prime, when you substitute 1 in this equation, you will see that you get 0. Your answer becomes 0. That's what they are saying. And which, when you substitute f is f of 1, when you substitute also what, 3, your equation get what, 0. So what you're going to do, you are going to say, you're going to test your values. You can start with 1, 2, but you must see, you can also see that if you can say 3 minus 3 there, because they already told you that f prime and f prime is 0. You can try 1, you see that if you substitute it in f of x, are you going to get 0 in f of x when you substitute it in f of x? If the one that you get f of 0, you are going to use it for long division, then you do exactly the way we do it to sketch the graph, everything. So just let me, beside that, not to confuse you, let me just let you do it, because we already did the one for like plotting the graph. So you can just plot the graph. Let's start with all the things that you know about plotting the graph.
So I'm using the f of x.
Yes, f of, you are writing everything that we did in it. Answer that question based on what we did, how to plot the graph, the way I was teaching you.
Okay. No, I forgot. I'm even writing on the book.
You forgot?
No, I didn't book. I'm writing on the instead of the tablet.
Oh, okay, it's fine. Then which means you can write, then you write again here in the board first some of the few things that, there are things that you can just, when you are done writing, you can copy them in the book, only the coordinates, so that you can be able to do what you can be able to do to plot the graph. Yeah.
Oh, but then we already did this.
Yeah, you shouldn't have done it. I'm just letting you do it because you want to do it. You should have just wrote the final answer that you have before.
I don't want to get confused. That's why.
Yes, that's the point. If you don't want to get confused, then show all the steps first. There is no way to, you don't have to run anyway. We are not going anywhere. We're not in rush. There is nothing wrong with showing all the steps so that you don't make mistakes. You might be not showing all the steps, you make mistakes, you get 0. So I'm happy with what you are doing.
And then this is my formula to find the y.
Hello? Yes, yes.
Then y is equals to 0.
Yes. The results that you get, you write it. As long as you are doing the right thing, you won't go wrong. You can write the coordinates, which means when x is 0, y is also 0. You write them down, you move on to another one. Okay, so now you are going to get the x-intercept. So which means now you are going to be checking the value for when you substitute there, which is gonna be equal to 0, right?
That's it.
For x. You will get it. You can think. We got all the time here.
And then how do I check which one is the maximum value or the highest?
The one, in that equation, it was more easier for you to see that 3, if you substitute 3 there, is going to be 0, because the equation says x in brackets x minus 3. So if you say 3 minus 3 is going to be 0, you see. So which means everything was going to be 0. So you can, that's how, like, you must just try to find a value. Like, when you look at the equation, try to think about what can you do that value, it can be 3.
Okay.
You get my point, eh?
You are right. Also, when I'm finding the value, I have to look at this number here.
Yes, you were supposed to look, but now here we have 9x, you don't have another number plus as a constant that you can divide with. So that's why I'm saying you can first maybe take out that one. You will see that if you take out x the way it was, né? But when you take it out, it's going out x, it's going to be the 2 there. So it won't really work. Even if, let's say, maybe for example, because there is minus 9x, if you take minus 9 divided by 3, you can see that it's gonna give you 3. So 3 is gonna work.
Okay.
But you must actually, this what I'm saying is not, you must make sure that you just test all the values. You test the value. You can start from 1. If you say 1 is not working, 2 is not working, 3 is not working, maybe you try 4. Then you can try even 1/2. Then after that, if 1/2 is not working, then you repeat all those values from starting with a negative now. Did you verify that that's exactly is 9?
Well,
Everything that you just did there, did you make sure that is 9 equals to 0?
yes, I did verify.
Oh, okay. That's perfect. Hello? Alright, you got, that's what you got, ne? Let me just wait, let me just verify everything. Minus x squared, okay, x minus x squared plus, okay, it's fine. Then we're gonna get minus 3x squared plus 9 minus 10x, you divide minus 3x minus, okay, yeah, it's perfect. Then now you know what to do. The second step, you can proceed. That's nice, eh? You are doing it, you did it perfect. Do you know what to do up to this side, this side, ne?
Yes, I'm just looking down the
Okay. Remember what you are writing is f of x, ne? In a factorized way again. Then if you take, no, it's fine, do it like that. You were right, ne? In the other one you have x squared minus 3x squared. Take out x there.
When?
Take out x. Factorize x squared minus 3x. It was 3x there. What you wrote is fine. Okay. For 3x squared minus 3x, you can just first take out x, ne? You will see that you're gonna be left with x minus 3x, 3.
Also, I don't need to do all of this. I just,
No, that one you don't really have to.
like this.
Yes, you take out, you will see that you're gonna be left with x minus 3. So now x minus x, x minus 3 only, because not because you are taking, you are simplifying, factorizing. So that x is still going to multiply. When you multiply there, if you multiply by x now, it's going to have minus 3x squared. You won't get 3x. You made a mistake there. You don't have to move.